Hello AAT, we are continuing. This is part 3 of video 3.1 on polynomials. And before we looked at the last part here, we'll say part C, part 3. I wanted to talk just a second about roots and changes in direction. If you have a cubic, the simplest cubic curve is going to look something like this. Notice it never changes direction. It's always increasing. So it has one direction and it has one real root. But if I start making changes to that graph, like maybe add in some x squareds or x to the first, blah, 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 other things there, it's going to start moving around. And it's possible that it'll have 3 direction changes. So a cubic is going to have 3 different directions and have 3 or 1 real root. So notice this one only has 1 x-intercept. The other roots are imaginary. So if we factored this thing out, it might be something like, for instance, this root looks to be about at -4. So it could have a root like x plus 4. But then it might have some imaginary roots, like if I had something like x squared plus 2. If I set that equal to 0, x would equal plus or minus I root 2. So 2 of the roots are imaginary and 1 of them is real. So that's why these roots always keep going down by a negative number. Let's say, for instance, you have a x to the 6 polynomial. So maybe or maybe not you have x to the 5th, x to the 4th attached on. So what's possible? You have as many as 6, 1, 2, 3, 4, 5, 6 different directions. Or if it looks a little different, maybe we go down and it has 1, 2, 3, 4 directions. Or it's possible we go down by 2 and it has, let's see, we had 1, 2, 3, 4, so now we're going 1, 2 different directions. So again, 6, 4, 2, going down by an even number. Look at the roots. This one has 1, 2, 3, 4, 5, 6 roots. This has 1, 2, 3, 4 roots. This has 1, 2, and we're talking about real roots subtracted by real numbers. So that's what can happen. So at most 6 roots in 6 different directions. So here we're looking at minimum, maximum, increasing, decreasing, and end behavior, which really our whole goal here is to be able to graph any polynomial that gets thrown at us. So a relative minimum is the greatest y value among nearby points of the graphs. Relative, I said minimum, I meant maximum. It's just the high point. It's the top of a hill somewhere on your graph. So like if I look at my graph here, I've got a maximum there and a maximum there and a maximum there. These are all relative maximums. There is none on this graph. A relative minimum is the smallest y value in the graph, so maybe like there. Intervals increasing are all the x values for where the y values are increasing, and decreasing the x values where the y values are decreasing. And that's what we talked about on the previous page. So in behavior, if you have an even degree polynomial, so like an x to the 2nd or x to the 4th degree, if the leading coefficient is positive, both ends are going to go up. So for instance, if you have y equals 3x squared plus blah, 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 or y equals 1/4 x to the 8th plus blah, blah, blah. Notice positive leading coefficient, this is positive, and even. That means no matter how many ups and downs you have, both ends are going to end up going up. as opposed to if it's an even degree, like y equals 3x squared, again, plus blah, 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 but it's a negative leading coefficient, or y equals negative 1/4 x to the 8th plus blah, blah, blah. It's going to both ends go down. So it might have who knows how many humps. It might only have one direction change, maybe a bunch, but both directions are going to go down. So even degree has both directions end up going the same way. If it's negative, going down. If it has a positive leading coefficient, going up. We write it like this, the end behavior. As x gets bigger, y gets bigger. As x gets smaller, y gets bigger. So in other words, the y is going up both times. As x goes up, y goes up. As x goes down, y goes up. Okay, so this is going right, and this is going left. Okay, negative leading coefficient as x goes right, y goes down. And I might want to put as here. And as x goes left, y also goes down. Both ends go down. Now, odd degrees, like a y equals an x to the 3rd, if it's a positive leading coefficient, a positive number here, it's going to start down, might have a bunch of humps in between, end up. Like y equals 7x to the 11th plus odd degree positive leading coefficient, starts down, ends up. So here as x goes right, y goes up. As x goes right, y goes up. As x goes down, as x goes down, y goes down. Again, we might want to put an as in there. And then last one, if y is a negative coefficient, but an odd degree, plus a bunch of other stuff we don't care about, it's going to start up and down. Start up and down. Maybe do ups and downs on the way. As x goes right, y goes down. As x goes right, y goes down. As x goes left, y goes up. Okay, so let's try a couple. On this first one, I have a negative leading coefficient and an even degree. So an even first degree means both ends go the same way, but it's negative, so both ends go down. As x goes up, y goes down. As x goes down, y goes down. Here, check and make sure these are in standard form, but this is an odd leading coefficient and still a positive. Sometimes it might help to draw it out first. I don't know how many humps it has, but I know if it's positive and it's odd, starts down, ends up. So as x goes right, y goes up. As x goes left, y goes down to negative infinity. Negative leading coefficient odd, so that means starts up, ends down. As x goes up, y goes down, down to negative infinity. As x goes down, y goes up. And positive leading coefficient even means both ends go up. So as x goes up, or x goes right, y goes up. As x goes down, y also goes up. Okay, that was a long 3.1. So now go practice.